Hello and welcome to this episode of the AI show. I think I'm too loud. I feel like I'm too loud. How's it going, everybody? It looks like, hopefully, for many of us, it is Friday this week. Again. Didn't every week, every day this week feel like a Friday? I mean, serious. This has been the longest week of my life. Anybody else? I don't know if the longest week of my life. I feel like the last 2 years have been the longest years of my life, for sure. We're going to try to have a little fun today. We're going to be doing a couple of things. A week-long Monday, Shane McCormick says. Yeah, it feels like it's been a week-long Monday. Seth AI, you know what? There is Janiscu number 7. We're gonna have to. Does it pronounce Janiscu number 7, or am I being too formal? Is it just Janiscu 7? I think I've been too formal the whole time. I forgot what I was saying. But today we got a couple of good things that we're going to be doing, and hopefully we get some stuff done today. Let's share my screen here. Beep boop. Beep boop. Howdy doodle. Where's everybody coming from, by the way? Today, number 1, we're going to do a pass number 2 at AutoML for images with my friend Serge. With Serge, he's from Paris. Man, my handwriting's awful. Serge from Paris is going to show us how he actually took AutoML for images and did some cool stuff. Now, the thing about it is he was totally willing to come on live, but he literally lives in Paris. And so I was like, no, brah. So I recorded earlier with him today at 8 in the morning. And if you have any questions, we can totally go in and do some doc diving to see what we can learn together. I think it's a cool product. So we're going to do that. Number 2, remember, we left off last time where it actually worked. Ish. And when I say it actually worked, I mean our rock, paper, scissors project. One of the things I'd like to do is maybe explore ways to give the system more pictures when it makes mistakes. And the other thing is that I find the process of when I commit code to get to the model and in production takes too long. And that's probably because I'm training, exporting the model, building the endpoint and all that. I think I'm going to try to make my GitHub actions a little more precise so that if the scoring file changes, it only redeploys the model. But if the training file ends, does stuff, then it does the whole thing. So we're going to do some janitorial work on our project. And then Avi, because it's like the day before the holiday for some people. If you're not taking off, that's okay. Oh, why did I zoom in? That was cool. I don't know how I did that. We're gonna take questions. Delete. We're gonna take some questions. So that's what we're doing today, friends. I'm pretty excited about that. Let's see who we've got. Jay McCormick, downtown Seattle. Welcome. Not far from where I live, actually. Oh, man. My AI is like, hey, you talked about Seattle. I wasn't talking to you. Sharafudin, good night, my friend. How are you? DF Mera, bienvenidos. Welcome. It's good to have you. Who else we got? Okay, here we go. I'm gonna have to move this over here so I can read it because I'm old. I'm stuck on AI document extraction and indexing using HTML pages. Still new on this, but the diff between document extraction skill and the document cracking in the air example would be very helpful. I may be able to help with that, actually. I wrote the talk that does that. So maybe we'll get to that here after our, after we get to our show stuff. Look at this cool little setup here. I can do this now. After we get through this AutoML for images thing. Wow, is this laggy? My mouse seems to be moving slow. And did I tell everyone? Did I tell everyone the good news? I got a new computer. And I wanted to show you again the gloriousness. Look at that. 3080 That was my own sound effect because I don't have a whip sound effect. Yeah, NVIDIA. We ran that bad boy last time, and then the other thing was this goodness. Check a look. Take a look. Take a look at this AMD Ryzen 9. Thank you to Damian Edwards, who is a PM on the ASP.NET team. He has a hobby where he just enjoys doing this stuff. I know I showed it, Jay, last week, but you know what? I'm still very happy. I played a game of Minecraft the other day, and it didn't take a long time. It was glorious. Look at this. Look at all these cores. I'm not even using this one. What is this one doing? Just sitting around, CPU 31, just like, hey, you know what? I'm chilling. I'm chilling because it's almost our day off. What are you doing, CPU 31? And the other thing, too, is this. Like, you know how you open an Edge browser and then the world slows down? It's like, I'm going to open Edge. And it's like, hold on, I have a deep voice. Well, now it doesn't do that for me. Now look at this. All of this RAM right here just sitting around like, hey, fill us up. Fill us up. I will. And then this disk is just glorious. Look at it. It's just sitting there and thinking, I'm ready to work. Ready to. What was this little spike over here? What we got going on over here? What's good? All right. So what we're gonna do is, like I said, we got Serge today. Let's see. Here's a question. How do I use AutoML and other AI stuffs in the world of ASP.NET Core, Blazor, WebAssembly, Server, Web Application? Yeah, I would honestly, I'll show you. I'll do the endpoint. And the app that I'm going to build basically calls that endpoint, so it could be really built with anything. I decided to use React because I was trying to be cool, all right, to be honest. I know, 31, just do something. Just sitting around. Hello, Emily. Welcome. Glad to have you here. Yes, all the new CPU, lots of cores. Yeah. I will say, though, that my room has been getting a little warmer because of it. But I'm okay with that. But still, I mean, look at where'd that go? Look at CPU 31 here. CPU 31. Where are you at? CPU 31, look at that. Dude is just like, I'm just gonna sit here and do nothing. Just gonna sit down and think about life. Feel the breeze in my face from the fan that's cooling all the other virtual CPUs. It's happy. Look at it. It's just living life. CPU. Oh, yeah. CPU 31. Oh, no. Look at this one. CPU 27 also sitting here just like, you know, I don't have anything to do. It's almost Friday. It is Friday. So that's what's going on there with that. Okay, so let me get started today. I promised I would get to AutoML for images with Serge. He's awesome. I had a really good time. So what I'm going to do is I am going to... Oh, what am I doing here? Remove this. You guys are seeing behind the scenes. How embarrassing. So let me go ahead and add... this file so we can take a look at what Serge did. So hold on, I'm hearing all these extra things here. Let me close some. Oh, that's why. I had Teams running and still CPU 31 wasn't doing anything. You know what I'm saying? It doesn't have anything to do. All right, so what I'm gonna do is I'm gonna start this. I'm gonna start this so you can get a load of Serge and the cool stuff he did. Starting. You're not going to want to miss this episode of the AI Show where we talk about how to automate custom vision model creation with AutoML for images. Make sure you tune in. Hello, Well, welcome to this episode of the AI Show. We're going to talk about how to automate custom vision model creation with AutoML for images with Serge. Serge, how you doing, my friend?
Hello, Seth. How are you?
Fantastic. So tell us who you are and what you do, bud.
Hello. So I am based in Paris, in France. I am Serge Retkowsky, working for Microsoft since 3 years now, and I am mainly working on AI projects, including computer vision.
That's fantastic. But you actually work on real world problems, not like the stuff that I kind of make up, right?
Yes, that's correct. So currently, many companies and organizations are using computer vision for multiple kind of projects like predictive maintenance, healthcare, security, retail, autonomous driving, and so on. So the good thing is for computer vision is that it's very easy with AutoML for images available with Azure Machine Learning to build and train some new models to deploy this model into Azure, and then to quickly do some predictions based on images, because computer vision is not only analyzing content from database or database management system. You will analyze images, and images is just a collection of pixels, and it's very easy to build and train some deep neural network in order to help companies and organizations to take advantages of images or videos.
I mean, that's fantastic. So you're going to show it. You're going to talk about three real world scenarios. Can you describe them for us?
Yes, for sure. So let's take some examples. So the first examples I would like to share with you is how to use computer vision model for quality control. So quality control is key. Many companies and organizations are doing predictive maintenance, package inspection, product and component assembly, defect reduction, improving worker safety, and many additional things. So in this case, the first example will be about quality control, how to build and train a model, an object detection model with Azure Machine Learning and using AutoML for images. So I will quickly show you some examples. I have another example in the retail industry in order to count product from shelves. And the last example will be about how to detect fire from images and fire from a webcam, from example.
Awesome. Well, can we take a look?
Yes, so let's start with the first one. So as you can see, this is a Python notebook. I have previously built a custom vision model to detect quality control. So as you can see, sometimes there are quality control issues. In this example, this is not correct, and on the right part, this is correct. The beauty of AutoML for images is that it will automatically choose for you the best custom vision model and the best hyperparameter tuning parameters directly using AutoML for images. So first, I tried to analyze a collection of images. I was able to run AutoML for images to build and train my model, and then to deploy my model. And when your model is deployed, it's very easy to use it. So let's take a quick example. Okay, as you can see, this is just an image of a product. And as you can see, there is a gap here between these two blue pieces. So this is not correct according to this image. Let's have a look if our model is able to detect this. So I'm going to run live all the steps. And as you can see, yes, this is the first result. There is an issue with the package inspection. It says not correct with a confidence close to 80%, which is very good. And by the way, this is the location of the region where the computer vision model is analyzing the content. So what do you think?
That's cool. I mean, like looking at it, did you have to do much to get this to work, or like I see that the inference is happening, but how did you build the model? Like we talked about AutoML from images a couple of weeks ago. Is it just a question of giving it the images and letting it go?
Yes, so there was a dedicated AI show about AutoML for images. And the good thing is that with AutoML for images, You can do object detection problem. You can do image classification problem, instance segmentation as well. So what I previously did was to collect my images, to tag my images, and then with just a couple of lines like that one, I can do an object detection using AutoML for images, using, in this case, I am using YOLO version 5, which is very good for object detection.
Can you do me a favor? Press Control Plus a couple of times just to make the code a little bit bigger. Control Plus. There you go. And then if you scroll down, I see. Okay. I see. So basically, and I know we did a show on this, but seeing a real world case scenario is actually kind of cool. You basically tell it object detection, you're using YOLO v5, and you say go.
Yes, I just said go. Of course, it's always possible to add additional information, options, parameters, but just with a couple of lines, just say, okay, I want image in object detection, and I can pick up a framework like YOLO v5, and that's it. Yeah.
That's really. And how long did it take to train the right model? Is it like?
So in this model, it was a question of 10 or 15 minutes, okay, based on 100 images, not so much, okay, but it's a good starting point, and the quality of the model was quite very good based on my validation dataset.
And that's cool because going from an idea to a prototype of machine learning in 15 minutes, I think is quite cool, if you ask me. All right, what's the
Yes,
next example?
yes, it is quite cool. So as you can see, this is the results. And what you can do, it's always good to combine, for example, speech to text. If you want
The
to.
quality control prediction is not correct with a confidence of 79%.
Oh.
So this is just the use of our speech-to-text capabilities. So you can play this audio file directly from the interface, or you can send a message to a Teams channel. So of course, you can integrate Teams with Azure Machine Learning, and you can send a message to a team channel. Let's have a look. You will see there that the quality control prediction is not correct.
So now you're combining a bunch of cool AI things to alert people if there's something wrong. Because there might be a situation where it's imperative that someone get a message about whatever it is that's going on with the picture, and this is a cool way to do it.
That's correct. So the goal is in real time to send some alerts. So you can send emails if you want to, or just use a Teams notification, because with just a couple of lines, you can do it. Only when there is something wrong, in this case, when this is not correct.
That's cool. All right, what are the other examples? I know I jumped the gun, but this is really cool so far. What do you got?
So next example, it's about retail, okay? So we know that all the retailers have some issues with their products on the shelves, and they want to be able to detect if products are missing, for example, for the resupply. And this is another example. So it's still about an object detection custom vision model for that. But in this case, as you can see, I will be able to count the number of drinks. And I can say, okay, there is no more water, or there is too much sodas or whatever. And it's very easy to do. Let's go to the key part. So this is another new image, okay, that you can take from a camera or a webcam, for example. And let's run the model. And the model will say, okay, there is 18 drinks, Coca and Fizzy water and 7-Up and whatever. Okay. And same thing, you can automatically count the number of products. And in this case, it will say, I need to resupply 6 drinks because some drinks are left. And same thing, I can send a message on my Teams channel, and I know that I can resupply some products.
Oh my goodness. This is really cool because you can imagine a scenario where you literally have a camera pointed at the stock, and then every, I don't know, every night it just checks and it's like, hey, you need to put another 7-Up in there or something. That's really cool.
That's it. That's pretty cool. Okay, there is not so much things to do except building a custom vision model to detect the brands, and then it's very easy with AutoML for images and all the great options there to create, to build and train and to deploy your model. And one thing, you can deploy your model on the edge, not only on the cloud, but you can deploy it on the edge directly into a webcam, for example, or a CCTV.
Interesting. So the model that you build in AutoML for images, you can download and put it on any device that could run a model like that. Okay.
That's it.
That's cool. All right. What else you got for us, bud?
Okay. So next example is how to create and deploy a model on the edge. Let's say you have a CCTV and you want to be able to detect any new fire for fire detection. So same thing, I am using an image classification. I have built and trained a model using thousands of images of fire and non-fire. I was using as well AutoML for images from Azure Machine Learning. And then I deployed the model. And what we can do first is just to play a little bit with the model, just to see if we can detect a fire. So this is an image from a fire. It was in Paris a couple of weeks ago. The good thing is that nobody was hurt. So that's great.
Thank goodness.
And this is, we can see a fire, obviously. And let's call the model just to check. And the model says, yes, there is a fire with 81%. Okay.
Wow.
So imagine that you build and train a model on the CCTV, on a webcam, and in real time, it will be able to detect a new fire. Okay.
Yeah.
And what you can do as well using integration with additional services is that, let's say you have a fire department address. Okay, so you can retrieve the latitude and longitude. So it's an address in Paris, as you can see. And this is the webcam location. The fire was in Place de l'Opéra in Paris. So you can retrieve as well latitude and longitude. And you can use Bing to collect information like the time for the fire department to go to the fireplace. And in this case, it will say, okay, usually it takes 13 minutes, but at the moment, we have a lot of traffic jams, and the additional travel time due to traffic will be 99 minutes. Wow. And the good thing is that you can send a message to the fire department. This is the map, so you can take this street and then go to Boulevard des Invalides and so on. And you can use the big integration in order to display in a map the location between the fireplace. Okay, so we have a lot of traffic in Place de l'Opéra at the moment, and this is the shortest destination in order for the fire department to go to the fireplace. So another example. What you can do, of course, is to analyze in real-time videos. Okay, let's have a look in this case. So let's play. Okay, so as you can see at the beginning of the video, there is no fire detected. Okay, and then after a couple of seconds, you can see a car who is currently burning. Okay, so let's try to analyze this video using our custom vision model. And I can run the process. It will analyze some frames. At the beginning, no fire was detected. And now, after this frame, there is an alert. And same thing, I can have a notification on my Teams channel. As you can see,
wow,
fire detected at frame 240, 270, and so on. So I have real-time alerts. And as you can see, yes, at the beginning from my CCTV, there was no fire with 78% of confidence. And after a certain period of time, 100% of fire. Yes, because obviously the model was not wrong at this time. And that's it. So another nice example about how to use computer vision model in order to detect some specific events. It can be a car accident, it can be smoke detection, it can be fire detection, and you can run your model directly on the edge, directly on the video camera. So what do you think?
The thing I like about this the most, Serge, is that, I mean, I make AI models all the time, but I look at it from a clinical perspective. Like, is this model working? Is everything doing the right thing? I like the way, especially with the fire one, and obviously if fires are really sad, and if anyone had to go through super sad. But imagine a scenario where fire departments can be alerted immediately that there's a fire somewhere, and it tells them how to get there the fastest in the same instant. I think putting that all together is actually really cool. How did you come up with these scenarios, Serge?
It was just a curiosity. What is good with AI is that, of course, you can spend some time to build a model, but think about a full integration with any solution like a CCTV or like any specific equipment. What you want is not only to predict something like the fire or to do any kind of prediction. Maybe you want a little bit more. You want real-time notification, okay? And if you need to go from a place to another one, if you can have the shortest, how to say,
Route.
path or
Yeah.
route, that's nice. And the shortest will depend on the time of the day. It will depend on the traffic jam. And using integration with Bing, you can have everything, included the forecast, for example. So at the moment, there is no rain, mostly sunny, and you can have additional information. So you can create an end-to-end solution with a combination of multiple Azure services, and of course, including our custom vision model, which is key in this kind of application to detect a fire or any specific event.
I love it. So where can people go to find out more, my friend?
Sorry?
Where can people go to find out more about how to do this?
So if you want to learn a little bit more, of course, there is the official documentation from AutoML for images. And I made a dedicated GitHub repo where you can find more than 30 Python notebooks. All of them are available for free, I mean. So if you want to evaluate AutoML for images, you can use or leverage my demos notebook if you want to start evaluating AutoML for images.
Awesome. Well, Serge, thank you so much. Everyone go check out those notebooks. They're really cool. Thank you so much for spending some time with us, my friend.
You're welcome.
You've been learning all about how to automate custom vision model creation with AutoML for images with Serge. Thank you so much for watching,
Thank
and
you.
hopefully we'll see you next time. Take care. How about them apples, huh? I forgot to turn my mic up. Oh my goodness. Wasn't that cool? Like the thing that I like the most about Serge is we usually when we talk about like some of the stuff, you know, that Azure does, because I work for Microsoft, disclaimer, is we usually show like, here's the thing and here's how you use it. The thing I like about what Serge did is he's like, okay, let's assume you already know how to use it. Let me show you some ideas on how to make it actually useful, which I think we should spend more time on. So that was pretty cool for me. All right, so let's take a look at some of the questions. 31 is right, not doing anything. Richard, 100% right. The question is, how do I use AutoML and other AI stuffs in real-world ASP.NET Core? The reality is that state-of-the-art machine learning is probably done in Python. Some of the folks that like R might disagree with me, but that's okay. So it's either R or Python. But the output of those exercises are models, and those can be consumed really anywhere. Now, I'm not sure if the Onyx runtime works. So if you want to do client-side inference using the Onyx runtime inside of a Blazor app, I'm not sure if that would work. I would probably have to ask the Blazor people. You know what I'm saying? Yeah, we'd have to ask them. So that's a good question. The other question is, do you think AutoML can be used in Blazor? If not, do you think AutoML can be used in Blazor? If not, then why Blazor? So yeah, I think the cool thing about AutoML in general is I think you can use REST calls to instantiate like an AutoML job, or you could use the SDK. I don't know if there is a C# SDK for Azure Machine Learning, but if there isn't, there's still REST calls that are documented. You could run everything directly from the client. You could instantiate and create a new job, and you can manage the images, you know, in a Blazor, you know, client-side app. and send it and say, hey, run a machine learning thing, and then it does it over there. And when the model's done, you could either call it via an API or you could embed it into the Blazor app if, again, asterisk, the Onyx runtime works on the client side. Let's see what else. A good question. Oh, greetings from Nigeria. Welcome, my friend. We're so glad you are here. The only places I've been to Africa are Northern Africa. I've been to Morocco, and then I've been to Kenya. Those are the only two places. But Nigeria is like not even anywhere near. Africa is a beautiful continent with many countries and many diverse sets of people. In fact, one of the richest people in the world at one time was from Africa. He would walk around and just like gold would fly out of his hands. I mean, Africa is a beautiful place with a wonderful history. I wish I could travel. I guess that's what I'm saying. Okay. I wish I could go see you. Very cool indeed. Absolutely. This is awesome. I had a good time talking about it. Onyx runtime works with C#, and there is a Notepad editor in VS 22. Yeah, so great comment. Like I said, the Onyx runtime, if you're doing it on the server side, for sure you can get an Onyx model to do the inference. I'm not sure if the Blazor client side app could run the model natively in the browser. That I'm not sure about. It's a good question. Richard is saying my 27th is a bit too big. Your 20, yeah. CPUs are awesome. Next question. MLNet implemented it in AutoML. Yeah, there's an AutoML implementation in ML.NET. That is true. And I think it runs it locally, if I remember right. How can you use in a Raspberry Pi? That's a good question. So usually the output, let me put some music on here. Oh, it just finished. I have this thing running on a loop on, my third channel in my thing, and I think it just finished. So there we go. So the way it works is when you build these models, there's actually an output, a file output that has all of the weights that it learned. And what you do is you just wrap that in a little script, or it's called inference script, or a prediction script, and you can put that really anywhere that can run these models. So Raspberry Pis is what in the biz we call running it at the edge. And you remember Serge said you can run these at the edge. He meant like on cameras and things like Raspberry Pis. That's a really good question. Here's another one that I thought of too, and I was talking to him. Rochambeau with automated custom vision. Yeah. I thought about it too, but like the problem, I deliberately chose an easy machine learning problem because I thought it would make it go all of it go faster. The reality that is that the machine learning problem was the easiest part so far. Okay, let me share my screen here again. Boom. There we are. So we did that. Yeah. And maybe at the top of the hour, what I'll do is because I never have people talk back to me. Maybe I'll start like a Twitter Spaces. What is it called? A Twitter Spaces. And y'all can like talk back to me on the show. It'd be cool. But then I'll try it at the top of the hour. I've never done it before, so if everything goes completely wrong, it's okay. It's a Friday. All right, so now it worked-ish, the rock, paper, scissors thing. So let's go back to it and see what we got. Okay, here we go. Rock, paper, scissors. I think we do F5 here to run the function. Yes, indeed. We did all this. We don't need this. This was just to check things. What is the settings? Did we ever use this? Where do we use this? Go to references. Oh, yeah. It's just a function that we've encapsulated and run down there. Oh, here is terminal. Let's go to SWA start. Boop. And let's open a new browser. And we are localhost 4280. Localhost 4280. Boom. We want Camlink. We want Pro Webcam C920. Hi there. 2 of us. Is it like exactly synchronized? I think it's exactly synchronized. We don't need an extra camera of Seth. There's already plenty of Seths right here. Can you tell this camera's uglier, by the way? Everyone's like, no, Seth, you're uglier. Wow, my background music neglected to make my rim shot work. No, Seth, you're the ugly one. There you go. Hello, Beldathas. Welcome. How can I use how can I use in a Raspberry Pi? You basically download the model. Here, I'll show you. So this is an AI model that we've built. Here's the web bits. Here's the API bits. Here's the AI bits. So the output of any machine learning run is this thing called a model. I don't know why I have this board with sound effects, and I make sound effects with my mouth. Oh, that was really loud. I'm gonna turn that down. So this is actually the model itself, and this is metadata about the model that helps me do inference. So let's open that up. So let's go to Open, Reveal in File Explorer, Kapow. Oh, you know what? It's a new machine. So I don't even have Netron installed. So let me show you how to look inside of these things. We're just gonna look at that. Netron, pow, Netron app, Kapow, Netron, download. Beep boop, beep 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 beep. Hold on. Let's download this here. That's how the internet used to be, kids. I just want everybody to know. That's how the internet used to be. Okay. So let me open this. Let me install this this goodness here. Installing. Please wait. Netron. Bow. Then we'll just say File, Open. And we want C projects. And then we want Rochambeau. And then we go to the AI bits, outputs, model, and this is the model. So when you look inside of this model, this is the actual, why isn't it? Oh, control. Okay. Wow, this is the actual model. And if you look at it, it's not super complicated. Why is this model so dumb? Oh, I think this is our not smart model. All right, so let me download a more complicated model so you can take a look at that. And to do that, let me go over here. Let me go to machine learning here. Let's see here. No, I'll do that later. So here's where I store all of my models. And I think the last one we did was Rochambeau. I think it was a VGG19. So let's download this model. Let's give it a second. There we go. Model Rochambeau model number 3. That's not what I want to do. I don't want to remove it. So let's go to Rochambeau here. This is the last run, and these are the outputs from the run. And I just want to download the model. I think there's the ML model, and I want this outputs model. So let's do this. Let's go download outputs. And yeah, let's save them here. Great. Select folder. So it's downloading the outputs. You can see they're right here. This is because I ran this in the cloud. And the model, that's not the part we want. This is the ML model. This is the ML model that why am I blanking? This is the ML model that ML Flow outputs. Sorry, I'm slow today. So we'll download these outputs. So that model that you looked at here is actually like a tiny, a tiny model. It's supposed to do stuff. So basically, the image comes in at the top. There's a convolution, a ReLU, convolution, ReLU, max pool, ReLU, blah, 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 until it gets to the linear parts. Down here, you know, it's a generic matrix multiply, ReLU, generic, boom, 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 and then softmax, and then out comes the answer. So this is a tiny model. This is a baby model. But remember that model that we built for, as it downloads, that model we built was actually quite large. So let's go to that so you can see it. ml.azure.com. We built the model here in here because I didn't have the patience to do it. And if you look, you can see that we decided on VGG 19, which was the best one. So that's where I'm downloading this stuff from. Okay. That's where all that stuff is coming from that you're looking at. This is run 42 that we just saw, and the outputs are, oh, the job is using the new compute runtime to improve. Oh, hey now. I'm a fan of that. Boop. Okay. Let me go to full screen here, or just like half screen. So again, I'm still answering this question. So now that the thing is downloaded, there's run 42. There is the outputs, and there's the model. This is the model right here. So let's go to reveal this in File Explorer. And now I can click on this, and you should see, is this the same model? Why is it the same model? It shouldn't be the same model. Hold on, let's see the file size. Looks like it is the same model. Why is it? Oh, no. Except it's ginormous, 500 megs. So let's open this up. Yeah, I guess this is what a VGG 19 looks like. Although that seems weird to me. My computer's slow. Okay. My computer just got totally slow. Maybe now, let's see, CPU 31 is like, okay, there's some stuff to do now. What up now? Yeah, this is the model. And so once you have this model, you take this, and this metadata file, incidentally, if you're wondering, basically has some information about the model itself, how many parameters, what the size is, when it was built, and then what the classes are. So basically, you take this file and this file right here, and you write a little wrapper code around it so that you can score it. So here's what this typical scoring file looks like, and let me Control+ here, so it looks a little bit bigger. So there's two parts to it. Let me make this smaller because it makes it more confusing. And there's a lot of logging here, basically. So basically, you initialize by loading up the models. Notice I'm loading up these things, and then so there's a load, and then I'm creating these transforms that take an image and transform it into the right shape. And then this run basically loads the session, transform classes, all this good stuff. And it tries to load up the image into bytes, into an array. And then it transforms it, and then it runs the prediction on this particular model. And that's it. So you would have to put these files, the score file, the model file, and the JSON file that describes it, into a Raspberry Pi. And if it has enough compute power, it would work. So yeah, that's the answer to your question. Let's see what we. Oh, I know, the flashbacks, PTSD. Yeah, because we went over this a couple times, but every time someone new comes, I think it's good to like kind of remember it with some hindsight too, because I think, I don't know, I think it all just starts to make a little more sense. Okay. Good question. Stalling Netrons. Here's stalling Netrons. By the way, Netrons is awesome. It's weird to me that this is what the VGG 19 looks like. Something feels wrong. Let me go here. Let me go right here. Hold on. What did I just change? I didn't change. What did I change? What's going on? Oh, yeah. I need to install these things. I don't remember how, to be honest. And I need to install Onyx runtime again. Let's go to the model. Did I do it right? Yeah, VGG 19. Maybe that's just what it looks like. I mean, it's big, so what can I say? All right, so let's go back to our glorious deal here. And the thing that we were going to do is, if I put my microphone's in the way. If I put a paper here, Paper. It says paper, right? So that's the cool bits. So it's working. Now let's do rock. Yes. Scissors. This one may not work. Yeah, see it learned it like this, but like this. Oh, hey. Oh. 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 Interesting. So it kind of works, and that's what this is doing. Now, this particular app, I think it's time to pretty this up a little bit. What did we say? What did we say we were going to do? It worked. We're going to. Oh, that was it. Yeah, it worked. I think the other thing that's important is that remember last time we ended with like, hey, do you have an endpoint? And I made this endpoint and now it totally works. So I think I'm going to switch out. The secrets to the back end to run on this Rochambeau one instead of. But I have to come over here because there's like secrets and stuff. So let's change the endpoint here. So there's the endpoint. Let me put it into the secrets. Secrets on the back end API. This is the endpoint here. Beep boop. Okay, so I put that in there, and now it's time to put the secrets in there. Shh, secrets. So that's the secret. So now it's running on the actual one that we actually built, and I need to go into Azure and set those up on the. So here's what I just did. Under consume, it has like the endpoint and the thing. Now let's go to the portal.azure.com. Change the backend keys for the thing that is running. Okay, so give me 1 second. So here we go. There's Rochambeau. Then we go to configuration. And then we go to, so for example, you can see that in the, here's what it looks like. This is the static web app. I'm just changing the inference endpoint, the inference key. So let's edit those to have the values that we want. So inference endpoint is now going to have this new thing. There we go. Okay. Beep. And the inference key is now going to have this new key. And hopefully you're not seeing any of this because, secrets, schmeekrits. There we go. Then I hit save. And now, in theory, if you go to Rochambeau AI, this is the same thing that I'm running here, except this is running locally. So now I can close this. Let me go over here, this camera right here. And then if I do rock, over constrained error. I know that's true. Okay. There we go. Let's try it one more time. Oh, so something's wrong on the deploy. That's okay. We'll figure that out in a little bit. I wonder why but I don't want to figure that out now because I'd have to go into all the secret stuff. And who wants to do that? What's going on? Unexpected end of JSON input. Network. Predict. Headers. It returns a 500 error. Payload. Yeah, that's the image. Preview. Oh, service issue. Okay, so let's go to test here. Let's try it. So it looks like it works here. Now let's try with this thing that we predicted. copy. Okay. So we want image equals image colon, and then we go all the way to the bottom. This is a HTML encoded or base64 encoded image. That's this. Yeah, it still likes it. It thinks nothing is paper though, so that's not good. So something's not quite right. Something's not quite right with this. I'm not sure what's going on here. Same origin, payload is this, view source. Yeah, it's exactly nothing preview, timing. Okay. Yeah, not sure why this isn't liking life. Yeah, still ugly. Uncaught in promise, unexpected end of JSON input. Okay, we'll have to rebuild, but I think we'll figure it out. This is if you go to Rochambeau.ai. If you go there right now, you'll start to see that you can pick your camera and do your stuff. So I think that's pretty cool. All righty. We got this. We got this. Okay. Okay. Wait a minute. Let me make sure. Yeah, that's right. Hold on, let me check one thing. Maybe. Yeah, that's what I did. Weird. Maybe I have to restart this app. Okay. Maybe I have to restart it because I wonder if there's a way to restart. No, it should have just picked it up. All right. Okay. We'll figure that out. So here we are in this thing. There's the score.py. Now what we need to do is I think we need to clean it up a little bit. So let's look at it and see how we want to clean this up. Localhost 4280. Here we go. None. Okay. But why is it like I'm still doing things? What is it doing? I think we should put these side by side, number one. And then the other thing is we got to actually make it be a game. So that we're gonna make it like so that it tries. And then it says you win or you lose. Do you know what I'm saying? We got to do that. And then we also got to do a timer. Okay. All right. So let's see if we can get these things to be side by side here. How did we set this up? So there's the video thing. Let's go to this thing. I don't even remember how we did this, if I'm being honest. We did write it, though. Okay, so here is the... Oh, see, we have the canvas outside of this. How do we pass a reference to a thing? We should put these next to each other. How do we want to lay this out? Let's game plan this. So I'm thinking... Go with me here. I'm thinking we have like the thing right here and then a box, and then this thing is over here and this thing is over here. And then below we have a button that says play. And then what we'll do to start is we'll just randomly guess between rock, paper, scissors. If it's a none comes out, then I lose. I think. What do you think? Should we do it that way? Image here. Take this button down. The thing that I don't like is that the way we compose this is in the video component, we actually have the canvas. I wonder if there's a way to inject the reference to a canvas instead. We need to ask. We need to Google with Bing. React pass reference to component. Okay. Passing functions. How do I pass an event handler like onClick? How do I bind a function to a component instance? There are several ways to make functions have access to component attributes like this.props and this.state, depending on what syntax you want to build. Bind in constructor. Okay, well, we don't even do it that way anymore. Arrow function in render. Is it okay to use arrow functions in render methods? Why is binding necessary? Oh, I did not know this. In JavaScript, look at this. Here, let me control plus this. I did not know this. We're all learning something. Here, let me full screen so you can see this. In JavaScript, these two code snippets are not equivalent. Object.method, var method, object. Binding methods help ensure that the second snippet works the same way as the first one. I wonder if it's because it's a closure. With React, typically you only need to bind the methods you pass to other components. For example, button this handle click passes this handle click, so you want to. However, it's unnecessary to bind the render method or like. Okay. Why is my function being called every time? Make sure you aren't calling the function when you pass it to the component. Right. Instead, pass the function itself. Yes. How do I pass a parameter to an event? Bind. Interesting. Okay. Okay. Example passing arrow functions. Nice. Okay. How do I prevent a function from being called too quickly 20 times in a row? Debounce. Throttle. Holy cow. This is oof. Oof. Okay. Component state. Okay. So I think what we need to do is we need to lift this canvas out. We need to lift this canvas out and we need to put it next to this video thing. And what we need to do, margin top, is we need to flex it. Flex column. Oops. And then we'll put this canvas here. And I don't think we margin top it, but we just maybe. All right, let's see what that looks like. But we got to put a border on it. Otherwise, it's not going to be easy to see. Yeah, it's not going to be easy to see. Okay. View, inspect. Okay, so there's the video class. There's the canvas. And we want it to be... See, that's the problem we're having. One of those canvases is interfering. So let's go over here and let's take this canvas out. And the reference to the canvas is going to get mad. So we need to take that out. Use ref canvas. So we'll do this. So we'll take this out. Oh, I think we need to make it hidden because I'm like using it. Where are you? Where are you? I think I'm using this. Hidden. Okay, so let's go back here and let's refresh. It's still there. How do we? Let's see. Tailwind hide. Visibility. Okay, let's see. We don't want to take any row. Visibility. Invisible. Invisible. Okay. Because we're using this canvas to write the image thing into. I wonder if there's a way to do it without the canvas. Video.current. Video.current. CTX. And then we get the data URL of the thing. I wonder if there's a way to do it without the actual. Let's see. Let's ask. Okay. Get frame of video JavaScript. All right, here we go. Here we go. How to extract one frame from video. Input, but no, that's not what I want. All right, here we go. Here we go. Change video. Document create element. I see. So the way they do it is they create the canvas element, get the context out of that, and then what they do is they okay, I see what they do. I wonder if we have access to that. Document dot create element canvas, and then we can say const canvas equals. Then what we can do is we can take this out. And then what we can say is take this out, take this out, take this out, take this out. Take this out, and then we can take this out. Okay, so effectively what we did is we faked a new canvas that only lives inside of this thing, and then it gets thrown out. Okay, let's see if that works. Because that was one of the things that I was like, I don't like this. Okay, so refresh here. Notice that now there's only 2 canvases. In fact, let me just take that canvas out as well. Here, where are we at? Here, we'll take that out as well and see if everything still does what we want it to do. Because the frame comes out, and I wonder if I could use that frame to do the right thing. So let's go back to here. Let's refresh. Let's take, I don't know why it thinks camera 3 is the right thing. Let's take this, we'll hit submit. It worked. Although it thinks it's not very smart right now. So there you go. All right, so we fixed that problem. Now the next problem is we want to double box it so that when it sees the thing, it like overlays over top that it said paper or something. I don't know. Okay. So how do we do that? By the way, AI projects are funny, right? Because the hardest part of an AI project is making everything else around it pretty. Okay, so this is doing the right thing because, like I said, we're creating this ML element just to do stuff, and then we're on frame set sending the data URL out. So this now component is completely on its own. It just renders a video element, it shows it, and then when is there a button in here? Like, how does it know? Where's the button? That's the one thing. I wish the button's here too. I wish there was a way to trigger what I wish there was a way to take this button out. So then it would be a completely encapsulated, like, this renders a video with a device picker, which is a separate component. this renders a video. Here, let me put my face because everyone's not looking at me. This renders a video, and that's all it does. And then when you poke it, it sends the image out. So how? Let's see. So what we want to do, and this is the part that this is the part that always throws me a little bit. What we want to do is we want to find a way to how do we cause an event inside of a component? Okay, let's ask. Cause event in component. Oh, whoops. Oh, it's like shouting out it. Cause event in component React. How to set an event handler in a React subcomponent? That's the part. This is the part that's confusing to me. No. I bet we could do it on the click. See, this is that's a good question here. Like this button, I don't want in this video component. I could force it when we click on the video frame itself, but that feels hokey. I want to be able to like get a reference to the. I want to get a reference to this component and click it. So Janice Q7 saying hover and it shows a button. Yeah, I mean, I'm trying to separate. Maybe I'm just being too pedantic. I just want this thing to show a video, and then when it's poked programmatically, then it gives us the current frame. Right. So, for example, if I put a button outside on the handle button, let's just do some stuff. Let's just do some stuff. We'll make this invisible. Invisible. And then what I'll do here is I'll put a button below it in the main thing. So here it is. Should probably learn Emmet. And then there's no handle submit, so I'll put a handle submit over here. Handle submit here. And we'll take this out. And so in here, what we want to do is why is this like? Oh, yeah. Try. Button. Okay, so we don't want this one to be invisible, so we'll take that off. So what we want to do is on the handle submit, on the outside, we want to somehow get the video and tell it to set the frame. See, because the video is pushed out of this thing. We want to push it down. Automate it without user input. Yeah, I like that too. I'm trying to find a way to make this component self-containing. So that's a great question. Great comment there. So this happens because okay. So let me tell you why I'm having a problem. So inside of this thing, there is this video component, right? And what we're doing right now is we're saying inside of the component, it tells us when a frame is set. And it uses this on frame set, right? And we were triggering that with a button inside the component. What I'm trying to do is I'm trying to make this thing more dumb, so to speak, so that it just happily plays a video. And then from the outside, we say, hey, give us a frame right now. and then it just gives us the frame. Does that make sense? That's a little, I know it's fairly nuanced, but then I can reuse this video component anywhere, right? I can do cool stuff with video and a picker, right? Because the picker itself, notice the picker doesn't care. But maybe we did something in the picker. Yeah, but this event, that's a pretty important event. It's basically when you pick it, then you send it out. So this does not behave that way. But in the video one, there's got to be a way to push on it. Let's see if I think I have an idea. Let's see. Invoke click event on a button in a component. Okay. Call a component on button click event. Here we go. You can use state to dynamically render the component. Okay. First, to make the button render, we need to invoke the function. And of course, edit this. This is so old. What is the right way to invoke a button's click event? Put the business logic that you want to execute in a separate method, do save, and then direct. Yeah, and see, that's the thing. Like, there's no way. I see what they're saying. There's no way to do that, though, because so far as I know, this is a function. And so there's no way to have like a function unless I create like the actual component. The class component. You know what I'm saying? Unless I create the class component. Okay, let's see. Let's go back. React. Oh, here we go. Here we go. Okay, check. So let's get started. Setup. Yeah. Okay, button. Yes, no. Yeah, okay. 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 I just don't see. Oh, here's call component. What does that do? Let's see here. Call component. On click. Add component. See, but like I can do that. But how do I call a click on that, right? Okay, let's try the next thing. React on click event handling. React on event example. That's easy. I know how to do this. Rendering components in on click events. React's on click event handler explain button, blah, blah, blah. How to call a component on a button click. Here we go. You can give a button a function that is called when it's clicked. Yeah, I'm already doing that. It's just I don't know why it's not doing that. Automate it without okay, we saw that already. So I'm wondering if the only way to do that is if I do like on click equal handle submit. And I wonder if there's a way to, I think there's the way to do it with refs. I don't like that either, to be honest, because it's like, it feels like I'm cheating. So let's refresh this. There's no more button. What is this try? Okay. I remember what it is. So there's the camera. Now when I click on it, right now, that's when it does it. So now it's working, but I have to click on this. If I click on this, like, how do I get it? Maybe it's use ref. I think it's use ref. Okay, let me try refs. Use ref. We got the HTML video element. So now what I'm going to do is I am going to use the ref up here. And this thing that we're going to use is the video component. Video component. Can we do that? How is it a value? Yeah, see, it's a function. I guess we're just going to have to do the click. But see, if I do a timer, there's no way for me to... This is the part about React that makes me batty sometimes. Is sometimes I have no idea how to do the simplest thing. But then once I figure it out, I'm like, oh. Makes sense. Let's take a look at use ref. Use ref React. Video component inside the button component. That's what we're doing right now, actually. But I don't know, like if I do that, if I click the button, how do I reach in to where's my mouse? Okay, React use ref. React. No. I want the actual use ref. Okay, reactjs.com. Okay, tutorial React. Did that. Time travel, picking a key. Docs is where we want hooks. We want use the state, effect, rules of hooks, building your own hooks. Hooks API reference. Use ref. Here we go. Use ref returns a mutable ref object whose .current property is initialized to the past argument, initial value. The returned object will persist for the full lifetime of the component. A common use is to access a child imperatively. Oh, which is what we want. So function block, constant input, use ref, null, input L here. Wonderful. Essentially, use ref is like a box that can hold a mutable value in its current property. You might be familiar with refs primarily as a way to access the DOM. If you pass a ref object to React with div ref, React will set its current property, blah. However, use ref is useful for more than the ref attribute. It's handy for keeping any mutable value around, similar to how you use instance fields in classes. Instance fields in classes. Interesting. So you can, in theory, hold in an instance field a method. In theory. All right. This works because useRef creates a plain JavaScript. The only difference between useRef and creating a current object yourself is that useRef will give you the same ref object on every render. Keep in mind that useRef doesn't notify you when its content changes. Mutating the current property doesn't cause a render. If you want to run some code when React attaches or detaches a ref to a DOM, you won't call. Okay. So we have a reference. We have a reference to this thing in the video. And it's this video thing that we're running this method on. Wait a minute. I think we may be already doing this here. So on select. I think we're doing this already. So here's the, this is obviously wrong. balanced frame, handle submit. I wonder if there's a way to be like, hey, ref equals, I don't know, my video. Let's see what it says. Property ref does not exist in intrinsic attribute. Let's see what this says. Control C. Oh, man. Here we go. Generics, blah, blah, blah. So the main problem here is that you're returning the result of React forward ref in your render, which isn't a valid return type for your render function. You define the forward ref result as its own component and then render that inside with it. Holy sweet baby Thor. Holy cow. With generics button string ref. Sweet baby Thor. My head hurts. Let's see what other hooks there are. Use imperative handle. Customizes the instance value as exposed to parent components when using ref. Okay, maybe this is it. Use imperative handle. Customizes the instance value that is exposed to the parent components when using ref. As always, imperative code using refs should be avoided in most cases. Forward ref creates a rack component that forwards the ref attribute it receives to another component below the tree. This technique is not very common, but is particularly so. Forwarding refs to DOM, forwarding refs in higher components. In the above example, React passes a ref, given a fancy button ref, element as a second argument to the rendering function inside of the React forward ref call. This rendering function passes the ref to the button ref element. As a result, after React has ref will point directly to the button DOM element. Interesting. It's a way of like exposing this thing out. So for more information, see forwarding refs. Ref forward is a technique for automatic passing ref through a component to one of its children. This is typically not necessary for most components in the application. However, it can be useful for some kind of component, especially in reusable component libraries, which is what we're trying to do. The most common scenarios are described below. Forwarding refs to DOM components. Consider a fancy button component that renders a native button. React components hide their implementation details, including their rendered output. Other components using fancy button usually will not need to obtain a ref to the inner button DOM element. This is good because it prevents components from relying on each other's DOM structures too much. Okay. Now we're getting somewhere. Okay. Here we go. Although such encapsulation is desirable for application level components like feed, story, or comment, it can be inconvenient for highly reusable leaf components like fancy button or my text input or my video thingy. These components tend to be used throughout the application in a similar manner as a regular DOM button and input, which is what I want to do. I mean, I feel like it's talking to me. It's talking to us. I'm turning the music up because it's going to do it. These components tend to be used throughout the application in a similar manner as a regular DOM button and input, and accessing their DOM nodes may be unavoidable for managing focus, selection, or animations. Yes, indeed. Ref forwarding is an opt-in feature that lets some components take a ref they receive and pass it further down. In other words, forward it to a child. In the example below, fancy button uses React forward ref to obtain the ref to pass to it and then forward it to the DOM button that it renders. This way, components using Fancy Button can get a ref to the underlying button DOM node and access it if necessary, just like they used a DOM button directly. Here is a step-by-step explanation what happens. We create React ref by calling React create ref and assign it to a ref variable. We pass our ref down to Fancy Button ref by specifying it as a JSX. React passes the ref to props ref function inside of forward ref as a second argument. We forward this ref argument down to button ref by specifying blah. When ref is attached, ref.current will point to the button DOM node. Okay. This is complicated. Oh, and he's like, this is why I use Blazor. Woo! Woo! Like it's literally giving me a headache. Forwarding refs in higher order components. This is also useful when you with higher order components, also known as HOCs. Let's start an example. HOC that logs component props to the console. Log props. Displaying custom name in DevTools. You can even set the display name. Okay. All right. Okay. Forwarding ref in function component React. There we go. You don't really need forward ref here. Please refer to why. Don't uppercase your component name. Blah. Pass your ref through any props. Use a hooky ref. Create ref. So they're saying just pass a ref in area ref. Interesting. Okay. So what they're saying is that in theory, I should be able to have a ref here. And this would be of type. Well, let's see what the ref is here. Oh, I think I used ref in device selector. Use ref select element. This would be React.legacy ref. Oh, shoot. Oh my goodness gracious. Why is this so hard? All I want to do is okay, well, I'm done with trying. I'll just poke the button for now. What we do need to do is we need to have a canvas here. So let me delete Control Z, whatever I did here. No. I'm messing everything up. All right, let's go down here. I had like a canvas before, but this is all wrong. Let's take this out. Okay. Now I need to go back and see what the heck I had in my code. Oh! By the way, if you want to look at the code and follow along at the github.com/AI advocates, /Rochambeau. Rochambeau. And let's go over to the web and public. Nope. Pages. And then index. Yep. And let's, nope. It's in components. API. No. Have I not checked this stuff in a while? Oh, it's in components. Hudderf. And then, nope. Go back. Nope. Video.tsx. And then we had this canvas. Okay. Okay. And then I'll put this canvas right over here. We'll take the ref out and we'll put a border so we can see it. Border. Okay. So now when we go back here, we should start to see refresh. And then we'll put this here. I don't know why this does not have the border that we want though. Tailwind border style, border solid. Okay. Okay, so now we should be able to see this thing. No? Oh my gosh. Sometimes I just can't stand solid. Border 2. So I did border. And then I gave it a color. We'll do. Okay. We'll type in border. Okay. When did the web become so hard, my friends? There it is. I saw it. There it is. Okay. So there's the canvas. What I want to do is I want to make sure that this thing lives to the left. So let's do layouts here. Layouts. Flex direction. Row. We'll do flex row. Where are you at? Here, flex. I did column, no wonder. Flex row. We do not. This is invisible, but this does not need to be invisible. Okay, so we go back to this. It's still not flex rowing. Use flex row to position items horizontally in the same direction as the text. Okay. Flex wrap. Flex direction. Flex row. Flex call. Okay. Oopsies. Then we'll say flex. Oh my gosh. You know why it's not working? Because I'm a goober. Boop. All right, let's try that. Inspect. It's invisible, but we want to do hidden. Tailwind hidden. We want display equals none. It's hidden. I did the wrong thing. It's hidden, not invisible. That would be here. Hidden. Okay, nice. Now we just need these things to live side by side. So how do we do that? Flex. Utilities for controlling how flex items both grow and shrink. And I think for me, the reason why it's not working is because these are not in divs. Let's try that. Div. No. Oh, see, it says flex row with 2 Fs. No. No. Okay. Okay. So we got that. We got that. So flex 1. So we got that. We did the flex direction. Now we just need to do like the flex. Order away. I wonder if this will do. No. Huh. Justify content. Oh, this is for grid. Do we want grid? Gosh, I always have a hard time with CSS. Okay, here we go. Someone say, wait, I saw a flex no wrap. Let's go over there here. Flex don't wrap. Oh, okay. I see what you're saying. Let's put it in there. Okay, so flex row. Flex no wrap. Whoop. Let's go back. Move it. There's a way to do this though. I did this once for my website, but I don't remember. Here it is. Here. Max screen LG MX Auto. That's it. MX Auto. Oh, wow. Look at that's kind of cool how they do this. Hey. Did it work? Test again. What else did I do? So there's a max screen, WMX auto, mid grid, mid block. Block, and what do we got here? Block. So there's the whole div. There's this div, block MB12. Okay. Block MB12. Class name equals block MB12. No. Flex rows. Maybe we take this. Why is it not doing that? Max large. Oops. Oops. No, why isn't it doing it? Okay. I think I need to put flex in there as well, maybe. Flex. Why doesn't it want to put it side by side? Oh my gosh. This is killing me. I am literally dying. Oh, let's fix this. Why? What is it doing right here? It thinks it's rock. Okay, let's see if we can't populate that canvas while we're here. Might as well do something else. Look at it differently. Set frame. We've got this. We need to get a ref on this canvas. Okay. Oh, dokily. Let's see here. Draw base 64. Oh. Interesting. Interesting. I don't know if I like that. Same thing. Same thing. I think that's the only way to do it. That's what everyone keeps saying, so we're going to do it that way because what the hey-ha. Alrighty. So we're going to say this is a const img equals new. Can we do new image? Now, how do we create a new HTML image, though? HTML image. There. Okay. Now let's see if this will draw the right thing for us, which is good. Oops, I hit the wrong button. Let's go. So I hit the wrong button. So let's go back over here. All righty. Refresh. Brasileiro. No, I am not a Brasileiro. I was born in California. What's going on now? It's like completely gone. Oh, here we go. Here we go. Uh-oh. Illegal construction. React creates image element. Oh, how did we create this over here? Oh, we use document.createElement. There it is. Let's use this instead. Document.createElement. Image. Okay, let's try that. Beep, boop. And it gets thrown away. Hopefully the garbage collector is like, see ya. Wouldn't want to be ya. Is this not getting called? Canvas use ref HTML. Canvas element. We had that here. Yeah, the video element there. We used to have a canvas element too. Let's see how I did that before. Okay. HTML video, HTML canvas element, right? We put a null in there to start. And then in the canvas, we did ref canvas. So let's see over here what we did. Canvas, use ref HTML canvas element null. Then what we said is we said canvas ref canvas, which is what we wanted to do. Ref canvas, and then we have the canvas over here. Use ref canvas canvas, and then what we said is canvas.current. Canvas.current. Maybe I need to undo this part. Oh, I didn't finish the code because I'm a goober. Oh, that was terrible. So, no, it's here. Yeah, that's right. I did it right. I thought I did it wrong. So image source is the frame. Context draw image. The frame. Because this is just saying the base 64 URL code. Draw image, the frame, which is an image element in draw image. Canvas image source. CTX draw image by image. Schminage. Oh, wow. That's a lot of stuff going on in there. Image on load. I think I should do on load. The frame dot on load. Use a little closure here. What? Well, this was a less than successful time. I'm not sure why it's not doing what I wanted to do. It's probably because my head hurts and it's been like Friday every day this week. You know what I'm saying? It's been like Friday every day this week. There you are. I wonder if this part is even getting called here. All right. Yeah, it's getting in there. It's finding its way in there. It's just not drawing it at all. Oh, shoot. I forgot to put in what our next week's show is. Next week's show, by the way, let me look at this here. Next week's show, I think is going to be a holiday special from iShiggle and B. So make sure you stay for that. And they're awesome. So hopefully you have a good time with them on that. And then after that, it's going to be me, best of again. I might stop in, though, because I haven't finished the best of. I was thinking what I put in there. Maybe we stop in and we do New Year's resolutions or something. Like get this project done and move on to the next one. Because one of the things I'd like to do, and holy cow, I got to start doing my walk-off music here. One of the things I'd like to do is I'd like to get some Hugging Face models and put them into production. You know, like there's a cool one that like You know how we used to watch like NCIS or like crime show dramas, and they'd be like, "Go to that image, enhance," and we're like, "Oh, well, apparently you can do that now with some cool models," and so we'll make sure to do that a little bit. And then I need to spend some time on making this like, because I mean I think it's uninteresting. I thought it would be easier to just like do this. Apparently not. For some reason, it just is not happy with me. So what I'll do is I'll try to make it look prettier just on its own. And then we'll go from there, and then we can start talking about like the data science bits of it a little bit. But like I said, it's wonderful being with every one of y'all. Anybody have any cool plans coming up for the break? Oh my gosh, is that a rock, paper, scissors? Yes, it is. Janice Scoot number 7 is the best. Yeah, so we'll try to fix this up, but I think what I'll do is I'll do a little design work. I'll try to design something and show you the design, and then go from there, because I don't know. I feel like we're almost done with this project. We're so close, but it's all just like garbage work. Making the div be in the center. Gross. So there is that. And then next year, I'm also going to try to make this like a packageable thing that you can literally like run and install yourself and have it all. And if you don't want to do the machine learning part, maybe I'll find a way to save the models, etc. But I think we do need to move to a place where we're playing the game, and where people, for example, that aren't that go to the website, when it makes a mistake, maybe have a way for them to say, you made a mistake, you can use this image in your next retraining round. And that way we can get this pipeline of a bunch of images coming in, and the thing retraining every Friday, and then it just getting better and better at at thinking about Rochambeau. And then the last thing is, Avi, I want to make sure that it also is very good at predicting like what people are going to do. So this and more next year on the AI Show. Thanks for coming. We'll see you next time.